Okay, this is for geometry. Like, if you were absent for the first week after the spring break, you may find this information very useful, because you missed something very, very important. But if you were in class, you may find that this is important as well because you were not following. So this hopefully is not going to be a video that is too long, but this is particularly useful for period 4, because on Wednesday, this coming Wednesday, the 18th, I will not be in school, and on the day, I think, let me double check what I want you guys to do. Period 4 Wednesday. Yes, you may have a worksheet, and there is a project that's related to this, which is also a summative grade. And but after Monday, you should be able to do this without too much problem. However, on Wednesday, when you're doing the project and you run into certain problems that you don't know how to do, you can always come back and check this video. Okay. Let's start. Trigonometry, as I said in class before, is very, very important. You can't leave geometry without knowing these 3 functions. And the short form for this is the Sohcahtoa. Basically, it's that sine theta. Theta is just angle over there is equal to something called the opposite over hypotenuse. Cosine theta is equal to something called the adjacent. That's why we have the A over there. Adjacent over H is hypotenuse. Finally, tangent theta is going to be opposite over adjacent. So these 3 functions are basically the basic of this, and is extremely useful. After this little chapter, you basically know everything about the right angle triangle. So far, we have Pythagoras theorem to go with it. We may have angle sum of triangle to go with it. But after this chapter, everything related to a right angle triangle should be there. So, if you were not in class, at least a few things you definitely need to know. To facilitate this, I'm just going to copy. Nah, I'm not going to copy it. I'm just going to give it some name. So let's call this angle A. Let's call this angle B. Let's call this angle C. So normally this theta over here will be replaced by A or C. Okay, we'll never do the B, and the reason for that is this is the right angle itself. The 90 degrees is never in this set of equations, so it makes it easier. There are only like 2 of them to choose from. So, for example, you need to know first and foremost what is the opposite, what is the adjacent, what is the hypotenuse. Hypotenuse is quite simple. If you remember from algebra 1. Hypotenuse is always going to be the longest leg of the right angle triangle. Or you can always just look at the right angle triangle, wherever this corner is pointing at, the right angle is pointing at, that is the hypotenuse. So that is the easiest one to find in a right angle triangle. That should be a given by default. Now, the opposite and adjacent is a little bit different. It depends on which angle you're looking at. So I'm going to keep the green for angle A. So opposite of angle A. So we are looking at this angle, angle A. Opposite of angle A is going to be right over there. So the opposite of angle A is going to be BC. Alright, so opposite of angle A is going to be BC, so this is going to be the opposite. And because we have only 3 things to choose from, opposite, hypotenuse, and adjacent, so the last one has to be adjacent of A. So adjacent of A, of angle A, is equal to AB. So if you were in class, this is nothing new to you. You should be able to do this without any problem. So opposite of A is BC, adjacent of A is AB, and hypotenuse is AC. So it depends on what kind of information you can gather. You will use sine, cosine, or tangent. It depends on the scenario. And then if I actually know the theta, if I actually have a number over there, that's going to turn into a number. And subsequently, whatever they gave us, we are going to use that. But in the basic sense, without any number, that's the idea of opposite and adjacent. So let me erase this because the question may ask you for something a little bit different. So I will keep the opposite of A and adjacent of A up here. The question may say, let's find the opposite of C. So I'll use red for this. Opposite of C, of angle C. Opposite of angle C, because this time we're looking at something a little bit different. We're not going to be looking at A anymore. We're looking at this angle. The opposite of C obviously is going to be, that line is going to be AB. Hypotenuse will never change. It doesn't matter which angle you're looking at. The longest side is still going to be the same. So hypotenuse will always stay with AC. So this is just the opposite of C. Because opposite is over here, hypotenuse over there, the final step is just going to be the adjacent. So adjacent of C is going to be BC. Just be very careful about what the question is asking you to do, and you're looking at the correct angle. Otherwise, your opposite and adjacent will get mixed up, and then subsequently, when you're doing all this sine, cosine, and tangent, all these kind of things, you'll get it wrong. So that's the basic idea of this. So let's move on to another question. Just do some simple example for you guys. For example, I have a triangle like this, and let's say I know one of the angle is over here. Let's say this is like 30 degrees. That's my 90. I'm going to put my ABC over here. If a triangle doesn't come with the vertex, they don't have a label, just label it yourself. It makes your life just that easy. So I'm just going to give you one of the side. Let's say I have this. Alright? So it's just a very simple triangle. I know one of the degree, I know one of the side. So it's reasonable to ask you, like, to find AB and AC. Most of the math question will be like this, or they can say, you know, find angle A as an example. So we want to find all of this in this order. So I want to find AB, I want to find AC, I want to find angle A in this order. Let's just do this. So I want to find AB. AB is over here, right? I know this angle measurement is 30. I know this is 5. So just like before, what you want to do is, when you have a simple triangle like this, you need to know which angle you're looking at, and then after that, try to figure out the opposite, adjacent, and hypotenuse. Hypotenuse is always going to be that one. It's not going to change. So opposite is going to be my AB, because that's where my angle is pointing. This is the only one I know, because I haven't found A just yet, so I'm just using this C. Because I have the opposite, I have the hypotenuse, so finally this has to be the adjacent. There are only 3 ways to go. So now, if I want to find AB, I am trying to find this length. I know that this is 5, I know this angle is 30. I'm basically looking at this, so what kind of information I have? I am looking for opposite, I have the adjacent, I have the angle. So out of the 3 things, the only function that comes with the opposite and adjacent is tangent. So if you don't remember, I have the opposite, I have the adjacent, so the only thing I can use is tangent. So that's basically how you go about doing this, or how to use this Sohcahtoa to help you. You marked up the things that you actually have, and then subsequently that is the function you're going to use. So in this scenario, I'm going to use tangent. Remember that sine, cosine, tangent, after you write this down, you're going to put down the angle measurements. If you don't have the angle measurement, it's going to be angle C. If you do have the angle measurement like this time, angle C is going to be 30. You're going to put 30 over here. It's equal to opposite, which is AB, over my BC, which is 5. So in this scenario, because we are trying to find AB, I have to do a cross multiply over here. Simply just put a 1 over there. So you can cross multiply this. 1 times AB is going to be just your AB. And so AB is equal to 5 times your tangent, 30 degrees. Alright. Sine, cosine, tangent, this lot is very difficult to do without a calculator, so I strongly advise you to use a calculator because you will not be able to get this tangent 30 on your own. So we'll just go to decimal, and let's show the keyboard. If you're on decimal, you want to find the sine, cosine, tangent function is under this key, it's called function. Okay, so click on it. It will show up. Sine, cosine, tangent, we'll talk about the inverse later on. One thing you do have to check, for all of the calculators out there, there's always a way to change something called the radians versus the degrees. Because we are using degrees, right? 30 degrees, 40 degrees, 90 degrees. So make sure this is click. By default, it's always on radian, so if your answer looks odd, just click on this button and check if you actually use the degree. So what are we trying to find again? AB is equal to 5 times tangent 30. So 5 multiplied by tangent 30 degrees. So the answer is going to be 2.8667. Let's take the 100th, 2.89. That will be fine. Okay, 2.89, not degree. What am I doing? 2.89. So this is going to be 2.89. Alright, so we got the first bit done. And then they said we want to find AC. We want to find AC. Because this is just like an example, I'm going to use the sine, cosine, tangent to show you. There are other ways. You can actually do a Pythagoras theorem over here with that 2.89. You'll be fine. But we want to do sine, cosine, tangent. So this time we are having, can I use blue? We have the angle, we have the adjacent, we have hypotenuse. So I'm looking for a function that covers the adjacent hypotenuse. Adjacent hypotenuse. So we are using cosine instead. That's how you figure out which function to use. So we are using cosine. 30 degrees is equal to adjacent, which is 5, over my hypotenuse. I do not know. That's the unknown. So we have to solve this. This is again a cross multiply. So 1 times 5, and then AC times cosine 30. The cosine 30, just treat that like a number. Okay, if you're confused about that, because it's a function with, this is just a number, it's just an ugly looking number. So 1 times 5. You're finding AC, so hopefully you'll be able to divide by this number. Just move this cosine 30 to the other side by division. It's hard to write this thing. That's how you get to the answer. So of course this bit you need a calculator for it. 5 divided by cosine 30, go back here, 5 divided by cosine 30. is going to be 5.773. 3 cannot round up, so it's 5.77. There you go. Not too bad. Finally, finding angle A. So this is something a little bit different. I actually want to remove 5.77. Okay, I actually want to remove this 30 degrees because some of you may be very tricky and say, well, we can just use triangle sum to find it. Then it's kind of like missing the point. So if we are going to find the angle A, which is going to be this one, we do not know what that is. But we have all the sides, right? We know that this is 2.89, this is 5, this is 5.77. We have all this side. It's actually really not too bad. One thing I do want to point out, if you go back to the decimals, when you click on the functions, on the very first column, you have the sine, cosine, tangent. Second column, they will call them the inverse. Okay, the inverse. They are the sets of keys that we have to use. The inverse functions are only used when you want to find the angle measurement of something. So in this scenario, I'm finding the angle measurement, so I'm going to use the inverse. I'm going to use the inverse. Okay. So let's erase off this because, as I said in the very first page, all of this other than the hypotenuse, it depends on which angle you're looking at. So be careful about that. Keep that in mind. So in this scenario, because I'm looking at the angle A, so 5 is no longer my adjacent. My 5 is actually opposite to A. So this time, this is the opposite. This is going to be the adjacent. So do be careful about that kind of arrangement. So I want to find angle A. I have all the sides already. It doesn't matter which one you want to pick because we've never done the sine. So we are going to use the opposite and the hypotenuse for this. So I'm going to use the opposite. We're going to use the hypotenuse to find out what the angle is. So I'll write this out just like before. Sine angle A is equal to my opposite, which is 5, over 5.77. Alright, now, if you get to this stage, you set that up correctly, there's only one more step to go. In order to get rid of this sine, you are going to use something called the sine inverse to get rid of it. It's very similar to square versus square root. Sine inverse will be able to cross this out. So it will turn into something like this. Can I move this apart? These things away. I'll just move it away. Okay, in order to do the inverse, what you need to do is A, because I'm trying to move this away, right? It's going to be sine inverse of this number. Very similar to something like a square. To get rid of a square, you do square root. If you don't remember, x squared is equal to 25. To get rid of that square, square root of 25. Exactly the same process. However, this time we call it the inverse, sine inverse. So sine inverse of this 5 over 5.77, go to your calculator. This time we are using sine inverse. 5 divided by 5.77 is going to be 60.06. So the answer is going to be, oops, I should use green instead. 60.06 degree. Okay, so it's just a simple example, and I hope that helped some of you who are absent for the first week. So I really want to say this one more time, just one more time. Sine, cosine, and tangent on its own is always about finding lengths. Okay, so it will be one side of the triangle, you use sine, cosine, tangent. And if you have, you want to find the angle, if you want to find the angle measurement, that's when you have to use the inverse. Okay, these two are very important. A lot of people mix that up, so don't make that mistake. Last thing, this is actually it's more for period 4, because I won't be there, and if you're doing the project, basically they will ask you a couple questions. And the project, it was about finding the angle measurements of basically a lot of different triangles, and you have to use sine, cosine, tangent at least once. There are 2 parts to it. The first part will ask you to find how steep the mountain is, or the mountain range is. To find something how steep that is basically looking for slope. Slope is rise over run. Okay, the simplest form of slope is rise over run. So let's say if you look at one section of the mountain, there's little triangle over there. How many times it goes up? Rise is 3. How many times it run? 1, 2, 3, 4, 5. 5. So the rise is gonna be 3 over 5. Alright? And then that's the first part. And then they will say, find me the angle measurements. 3 and 5. Okay, when they say finding the angle measurements of the mountain or something that's steep, obviously you're looking for the angle measurement that is formed with the horizontal line. So basically they want to find this angle over here. So just like before, you may want to put the A and the B and the C over here. That means when you find this, you have the opposite of A, and then you have the adjacent over here, and so you should be able to use tangent A is equal to 3 over 5, and subsequently A is, because we are finding angle, so it's tangent inverse of this. Now, the project actually says you cannot always just use tangent, because they do want you to do the sine and cosine as well. So what you may want to do is, for one of the mountain range, assuming it's another one, if you want to use sine, cosine, or other than tangent, what you may want to do is to find out this AB. To find this AB is really not too bad. You should be able to do a Pythagoras theorem on it. So AB squared is going to be 5 squared is 25, 3 squared is going to be 9, 34. So AB is square root of 34. So if you want to use another method instead of the tangent, you will have to find this side. So you have the hypotenuse over here. So instead of using tangent every single time, you may want to do, oh, okay, well, I want to find sine A. It's going to be opposite over my hypotenuse. Of course, I didn't do all of that. You have to use a calculator of this. So subsequently to find A is going to be the sine inverse. 3 over square root of 34. This bit is just really helping the period 4, and I will put that on. Yeah, I'll let you know tomorrow. Because I think, not tomorrow, I think I'll see you guys on Monday. So the last 5 minutes or so is just to help period 4. If you were doing the project and you have no idea how to do it, check this out. So that's basically a very short introduction, and not just introduction, we basically covered the sine, cosine, tangent already. It's a very important topic. If you were absent last week, make sure you check this out. Bye for now.